So this is what scientists are all about, figuring out how the universe works. But they always know, even if it's in the back of their mind, that everything they come up with to explain why the universe works the way it does can be kicked out of all the textbooks by somebody who comes along with a better argument supported by better evidence. Okay? It's all evidence-based. All right? All of this is evidence-based, so it has to be based on physical evidence. Okay? You can't just come up with any kind of argument. You can defend an argument all you want to, but if it isn't based on physical evidence, it's not science. If it's not based on physical evidence, it's not science. So it's based on physical evidence. It might be something else, but it isn't science if it isn't based on physical evidence. It has to be based on physical explanations. Yes, but we're not there yet. And sound reasoning. You can have all the opinions you want to, but opinions aren't science. Okay? Your opinion might become science if it's based on these things. If it explains something about the way the universe works, physical evidence, physical explanations, and sound reasoning. So there's a big difference between what science comes up with and an opinion. All right? Okay. So that's our middle circle there. That's what's the goal. That's what the aim is. So the way you get there, the way you get to this, may depend on what it is you're working with.
Is that based on physical evidence?
Based on physical evidence. Okay? Now, one thing we've been working on in this unit is how to write a formal table and how to produce a formal graph. Okay? What is the point of all that? Why would we bother doing that?
Whenever you get calculations of what you're trying to figure out.
Why put it in a table? Why put it in the graph?
Evidence?
Might become evidence. If you see a clear pattern, it be evidence of something that happens. You can make predictions about the future. If you see it goes in this direction or goes in this direction, that is the data. When you graph it, you can make predictions about future events, that they're going to behave in the same way. Okay?
Like the weather?
Huh?
Like the weather?
Like the weather. Okay? Now, there's so many things we can't control and figure out about the weather. That's why it's not as accurate as we'd like it to be. We love it to be more accurate, but we can't really do that yet. We're not that good yet with that. There's too many ifs, ands, and buts with all that. But I can predict with reasonable scientific certainty that it's going to get colder this year. All right? All right? Because I've seen it happen over and over again. So there's patterns there. Okay. So, but some of the bigger things that are harder to figure out, if we don't organize it, it's hard to tell. When you put it together in a table, when you organize it in some way that makes it easier to figure out what's going on, it makes it easier to make those predictions, hypotheses, etc., and so forth. Okay? So one of the things that scientists do is organize all the things that we know. Okay? And very often we also organize what we don't know so that we can try to figure out a way to find that. What we'd like to know. Now there are scientists who spend their entire career organizing data, gathering data. There are people with the Department of Natural Resources in this state who go out and keep up with how many fish there are in a lake. They keep up with how clean the water is, how dirty the water is. They keep up with the number of deer that are killed and how many are out there in the woods, in the forests. Okay, that's their whole job. Does that mean they're not scientists because they don't go through writing hypotheses and doing testing? Would we say somebody is not a scientist because they're not doing all those other things? No. They're collecting data. It might not be even data they use. Somebody else might use it. But they're part of that scientific process. They are scientists, okay? So this is part of that process. Simply organizing what we know and what we'd like to know. Some scientists organize and do all the other things too. Some only do the organization. They may spend their entire career just trying to map the human genome. Okay? Know what the human DNA looks like. That may be their whole job. Or most of their career doing that. They're not coming up with hypotheses. They're not coming up with other tests. They're just trying to figure it all out. Figure out what's there. And that's their job. Okay? Now there are scientists who go about generating hypotheses. Where do they get the hypotheses from? So the hypotheses have to be based on this physical evidence that somebody's organized. Okay? And then they have to be based on an idea about what might be causing the behavior. Those patterns we looked at yesterday in a lab, you saw a pattern. What could cause that pattern? And that's something we call a model. The cause of a pattern, what's underlying all that, what's causing it to happen, you can't see, you can't taste, you can't touch, what's causing it? Okay? That would be a pattern that would be defined by a model. The explanation for that is a model. Okay? So hypotheses then have to be based on a sound model. Okay? So some scientists are in the business of generating hypotheses. From models. 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 We'll just talk about what models are. Models are the explanations for why things happen. They don't have to be the right ones. They are proposed. They are proposed explanations for why things might happen. Hypotheses? Hypotheses.
You said models are explanations for why things happen.
Yeah. So I can look around the room and I can see that some people are really, really focused on what we're talking about here. And I can see some people that aren't so focused. I could come up with a model to explain why they're not focused. Okay? But it has to be based on sound evidence before it becomes science. Okay? If I say everybody who puts their head down on their desk is just lazy, is that sound science? No. What other explanations could there be? Huh? They don't feel good. They could be tired. You know, maybe their grandma died last night and they were at the funeral home. I don't know. All right? Well, I know it could be that's kind of a worst case scenario. Right? I guess it's not as bad as your mama dying, but okay. But anyway, the point is that we can have opinions, but unless it's based on physical evidence, and in this case a model based on that evidence, we don't have science. Does that make sense? So if I were to do some fact-finding first about students that fall asleep in class or don't pay attention in class, I could actually come up with some data, organize the data, and if I can find a pattern, then I can generate an hypothesis based on that. Does that make sense? Now, hypothesis is just a statement for testing. It's an initial statement put out there for the purpose of being able to test what your pattern looks like. Okay? All right. So, and we're going to talk about what a good hypothesis is later. All right, suppose we come up with a hypothesis, then what you got to do? You got to test it. Now, some scientists never get around to testing it. Some scientists never get around to testing it. There are things that Einstein proposed that he never tested. And it was after he died that they found evidence to support what he proposed. Okay? He proposed, for instance, that the faster that you travel, the slower time passes. Okay? They couldn't prove that while he was alive. They proved it after he was dead. So he generated an hypothesis, but he never could test it because he didn't have the technology. Okay? So sometimes scientists then are in the business of seeking evidence for these hypotheses. They're looking for that evidence. They may be doing actual testing. They're going out in the world and gathering data that's already there, but they're seeking evidence. Yep. Seeking evidence to test hypotheses. Now, sometimes it's the same scientist that came up with the hypothesis that does this, and sometimes not. Sometimes it's somebody else that gets around to it. Or the scientist who generated the hypothesis did some testing that supported the hypothesis. Some other scientist comes along and finds evidence that refutes or turns over that hypothesis, finds it not to be true. Does that make sense? Science is a group endeavor. Okay? Once you find something in the sciences, it's not science until you publish it and everybody else has a chance to look at it and other people have an opportunity to go and test it and see if you're right. Okay? Yeah.
What did you say Albert Einstein made a hypothesis on if you travel faster, time goes slower?
That was Einstein's idea, yeah.
That was his hypothesis.
Yeah, at that time it would have been an hypothesis.
What was his model?
He was, now you're getting a little too deep for me. I really have forgotten. I'd have to go, that's something I have to go back and look at myself.
No, because you said
It has to be based on a model. There were, astrophysicists were looking at evidence from their telescopes, electronic, digital, all those kind of telescopes they were using, and there were some things that didn't quite make sense. Okay, this is what I remember of it, and the details, I'm sorry, I don't have just out of my memory. Okay, but anyway, so he looks at those things and starts saying, why would that happen? Well, that's kind of what an hypothesis is. That's what a model is. Why is it happening? Why is this behavior there? And he came up with an hypothesis that would explain it. Okay, but that still hadn't been tested until somebody else came along and did it. Okay, I can remember a lot of what Einstein did, but there's a lot. He did a lot of things in a lot of different areas. He's a really neat guy when you start looking at what all he did. But then so is, he's a little bit weird sometimes, and so is Newton. But everybody's a little weird, right? Okay, all right. So now, once we've got the evidence to test the hypothesis, somebody's got to come up with a clear argument. And that might be the same scientist. But somebody's got to come up with a clear argument for those explanations of why the universe works, okay? So somebody is in that business, constructing the arguments. I'll say constructing arguments. Constructing arguments. So that's their business. Now, it might be the same person doing all this, or it might be different people doing some of these things. Or it might be that initially somebody came up with an argument that went along with all the testing and stuff they did, and somebody else comes along with a better argument based on that same evidence. Okay? Well, this is a big circle. Organizing data gives us what we need. If we look at the table and graph from yesterday, we have a pattern. From that pattern, then we can generate a model and then an hypothesis to test that model. Okay? From the models and the hypotheses, we can start looking for more evidence to test the hypothesis. We'll come up with an initial idea what we're causing it. Now we need some new tests to try and figure out if our hypothesis and model is right. Seek the evidence, test the hypothesis. Somebody comes along with the constructing arguments. And then we get to we're doing the goal, we're reaching that goal of science. All these things are part of the process of reaching this main goal of coming up with defendable arguments that explain the way the universe works. But you know what's really cool? Every time you come up with one of these new arguments, somebody starts organizing and gathering data based on those new arguments. And those organizations then either support that developing defendable arguments, or they end up refuting it